For years, humanity has relied on legendary observatories like Hubble, James Webb, and Chandra to reveal the hidden beauty of the universe. Orbiting far above Earth's atmosphere, these space telescopes have delivered breathtaking views that ground-based instruments were never expected to match. But something remarkable has just happened. A telescope that never left our planet has produced images so vast, so detailed, and so rich with information that astronomers across the world immediately took notice. The Vera Rubin Observatory has officially opened its eyes, and its first glimpse of the universe is already transforming the way scientists think about the night sky. These aren't simply beautiful photographs. They reveal a universe that is far more crowded, active, and constantly changing than anyone expected. Every image is packed with galaxies, newborn stars, ancient star clusters, and countless moving objects, offering a completely different perspective on the cosmos. At the heart of this achievement is an engineering masterpiece unlike anything built before. Its enormous digital camera contains an astonishing 3.2 billion pixels, making it the largest astronomical camera ever constructed. Each exposure captures an area of sky so wide that roughly 40 full moons could fit inside a single frame. That combination of enormous scale and incredible resolution allows Rubin to record details that previously required thousands of separate observations. Even more impressive, this is only the beginning. The observatory will gather an extraordinary amount of information over the coming decade, producing one of the largest scientific datasets ever assembled. Researchers expect to spend many years studying everything hidden inside these observations. Yet even the very first images are already filled with remarkable discoveries. Astronomers immediately identified interacting galaxies caught in the middle of cosmic collisions, regions where new stars are being born, countless ancient star clusters, and an astonishing number of newly detected asteroids. In only a few hours of observations, Rubin located more small solar system objects than many observatories discover over much longer periods. Moments like this rarely happen in astronomy. Scientists have dreamed of building an instrument capable of watching the sky almost continuously, recording changes as they unfold instead of capturing isolated snapshots. Rubin was designed to make that dream a reality. Instead of focusing on a single target for days or weeks, it repeatedly surveys enormous sections of the sky, creating an ongoing record of a universe that is constantly evolving. Long before its first image was released, the observatory had already earned legendary status among astronomers. High atop Cerro Pachón in Chile, one of the darkest and driest observing locations on Earth, the facility was built specifically to conduct an unprecedented survey of the southern sky. Its mission is unlike that of traditional observatories. Rather than studying one galaxy or one nebula at a time, Rubin was engineered to observe everything possible, over and over again, searching for subtle changes that would otherwise remain unnoticed. Powering this ambitious mission is the Simony Survey Telescope. Its advanced three-mirror optical design provides an unusually wide field of view while maintaining exceptional image quality across the entire frame. Combined with its massive 8.4-meter primary mirror, the telescope gathers enormous amounts of light every night. But the optics are only part of the story. Attached to the telescope is the largest digital camera ever designed for astronomy. Weighing nearly 3 tons and stretching several meters in length, it records ultraviolet, visible, and near-infrared light with extraordinary precision. The scale of each observation is difficult to imagine. A single image covers roughly 10 square degrees of the sky, an area equivalent to dozens of full moons placed side by side. Capturing that much sky at once would require thousands of individual images from telescopes with much narrower fields of view. Even more remarkable is Rubin's observing strategy. Instead of taking isolated photographs, the telescope repeatedly scans the southern sky every few nights. As new observations accumulate, astronomers will build an enormous time-lapse record showing how the universe changes over time. Variable stars brighten and fade. Asteroids race across the solar system. Supernova explosions suddenly appear. Entire galaxies continue their slow evolution across billions of years. Rubin isn't simply photographing the universe. It is creating an evolving movie of the cosmos itself. When the observatory released its first collection of images in 2025, expectations were already extremely high. Even so, the scientific community was stunned by what appeared after only about 10 hours of testing. One of the most celebrated images was an enormous mosaic of the southern Virgo cluster, the nearest major galaxy cluster to our own Milky Way. Built by combining well over 1,000 individual exposures, the finished image revealed millions of stars alongside countless distant galaxies spread across an immense cosmic landscape. Graceful spiral galaxies stretched across the frame with elegant arms wrapped around brilliant central cores.